Some would consider this blasphemy, but I'm going to explain psychrometrics without a psych chart. No psych chart. We have air in 3 different states here, and air is comprised of air particles and water vapor. So here, air particles are light blue and water particles are dark blue, and each particle has energy associated with it. And the higher the temperature or the higher the energy, the faster these particles are moving around. And for air, the more the particles are spread out, which allows room for water vapor to be stored in the air. So what we're seeing here is a bunch of fast-moving air particles mixed with a lot of water vapor. So this is a high humidity scenario and a high temperature scenario. The energy associated with the air particles is going to be your sensible heat, and the energy in your water particles is your latent heat. So what we have here is a high sensible, high latent scenario, which means we have high enthalpy. Enthalpy is just the overall measure of energy in the air. Now, this process here, if you cool the air particles are going to slow down and they're going to condense. And when they condense, they can no longer hold the same amount of water vapor. It essentially gets squeezed out of the air. So where does it go? The water condenses into liquid form and drains out of the air. This is condensation on a cold glass or dew in the morning. Or in an HVAC system, this is your condensate. This is at the bottom of the coil. And if you're smart, you have a condensate trap and you're going to drain that. So what we have in state 2 is low temperature air and low humidity. This is low sensible, low latent, which overall means low enthalpy. Now what happens if you heat the same air back up to the original temperature? That's what we're doing here. Now if you were to heat this same air back up to the original temperature, the air particles are going to return to the same state they were in before, the same amount of energy, the same amount of space, but you've condensed water vapor out of the air. So in state 3, you have high temperature air particles, high energy, high sensible, but you have less water vapor, fewer water particles. So here we've got high sensible, high dB, but a lower humidity ratio, which means we've got medium enthalpy. The enthalpy in state 3 is going to be higher than state 2, but it's going to be lower than our original state here. And what we just walked through here is dehumidification. This is one way of dehumidifying air. You cool it so the moisture condenses out of the air, and then you heat it back up. You return to the same dry bulb temperature, but with less humidity. And I can hear you begging me to plot this on a psych chart, but I'm not going to do it. We'll save that for another video. If you understand the physics here, it will make reading the psych chart a lot easier.